So now in this video, we have the same circuit as the last video, except instead of this trim pot, instead of this light dependent resistor, I used a trim pot wired as a variable resistor. So we only used two of the pins. So we would get a variable amount of resistance between the two pins. Now, we have a light dependent resistor in its place, and it fits there. So I actually stuck it in between pin 6 and 7 instead of having to rewire stuff, because that is large. So, in any case, we'll come back to the schematic. We'll zoom in. Actually, first, let's look at the power supply. So I have 5 volts right there and 30 milliamps of current, because we will exceed 20 milliamps of current at times. Power supply is off. And this capacitor here is just in case I bump the power supply or something. It kind of cuts power briefly and messes up the voltage. This relies on the supply voltage for how it operates. So it doesn't, like damage anything, but we don't get the nice smooth results we want. So I'm going to turn the power on, and yeah, right now we got, I just adjusted something. Yeah, you can already see like the current bouncing around. So it probably like briefly gets above like 20 milliamps, and I meant to that's not what I'm gonna do. There we go. So I gotta be kind of careful here. Yeah, no, it doesn't look like at the moment we are exceeding 20 milliamps, but that would change when this goes faster. So we have that. I can slow this down by covering it. Now we can get over hundreds of millions of ohms of resistance if we get this light dependent resistor dark enough. And so light's actually getting through my finger enough. If I put the overhead light there, it's going to take a lot longer. I could take, I don't have one floating around. Sometimes I do. I could pop the cap off of this. You just clamp it onto something. It gets wide enough. You can slide this off. And then I could cover it, and I think that's pretty much as dark as I can go. Like, you would never hear it click. So we can also turn the lamp off. So I have the lamp at the lowest setting right now, and there we got it brighter. So we don't quite have a tone yet. We have, I think it's kind of getting close, but when I get the light, let's keep that wider. Now let's zoom in. You can hear a difference as I zoom in and stuff. So like normally circuit like this, we wouldn't really wire a trim pot, but maybe we want a light sensitive circuit, in this case to change the sound. But with the Astable 555 timer, the output's going to keep going high and low alternatively based on primarily this resistance here. This resistance is involved with both charging the capacitor, both of them are, and then when the capacitor discharges, that's when the output's low. Pin 7 connects to ground, so it's like off when the output's high, and then it connects to ground when the output's low. They do the same. So when the capacitor is discharged, it just discharges through the light dependent resistor. So if we get a bright enough light on there, 220 ohms is really all of the resistance. There's just a speck of resistance, maybe like 20-30 ohms or something if you get a bright enough light. And then so that 220, then when the output goes low, instead of current going through both resistors, then it just goes through the one into ground. The current that comes through there also goes to ground. Hopefully that makes sense. So let's oh yeah, this capacitor is just to kind of steady the voltage. We have this capacitor charging and stuff, the output kind of kicking high and low. There's a little bit of resistance in the wires and stuff, and also the power supply doesn't respond to extremely rapid changes of current, not as well as a battery would. Here is the schematic. So again, I went into all of this into a lot more detail in the last video, except for I had a trim pot there, which can be turned down to 0 ohms of resistance. That trim pot up there, wired as a variable resistor, so only 2 terminals. So we could get down to 0 ohms of resistance, basically, not perfectly 0, between the 2 pins. Or if I turn it all the way the other way, we could get 10,000 ohms of resistance there. This one, again, we can't quite get down to 0, so it's not going to go as fast. We didn't get the buzz that we got with the trim pot in the last video, but we can get a whole lot more resistance. So a lower value resistor or capacitor there would probably be good. In fact, I think I'll swap those out. I bet I did that in the original video. Pin 4, you just put it to the positive supply. If it connects to ground, it holds the output low no matter what. The capacitor just keeps discharging no matter what. Once it's discharged, and all we got is the current going through there. No point. Pin 2 and pin 6 monitor the voltages. Pin 2 is the trigger pin. That's waiting for 1/3 of the supply voltage. Then it sets the output high and lets the capacitor charge. And then when pin 6, the threshold pin, sees 2/3 supply voltage, it tells the output to go low and also starts discharging. Now when the output's high, it doesn't connect directly to 5 volts. There's transistors in the integrated circuit that drop about 1.5 volts, maybe a volt at very low currents. So always be aware of that. I forgot to mention in the last video, but if you know a lot about, if you watch a lot of videos of 555 timers or read about them, you should already know that. And so in any case, yeah, we got that 10 microfarad. So it's the resistance plus the capacitance right there of the timing. And the passive resistor, or passive buzzer, just in case you haven't seen recent videos, you don't just apply power and it buzzes. That's an active buzzer. With the passive buzzer, you get clicks based on current going in, and then also current going one way, and then also current going the other way. So output's high, that pushes current that way. And then when the output goes low, without the capacitor, there'd be no current change. But the capacitor's charge, it discharges through the buzzer right there. And you get another click. And it doesn't limit current. So without the capacitor, as long as it's high, current's going to just keep flowing. And so with the capacitor, you get a brief movement, you get that click, and then the capacitor's charged. It can't move, or current can't move anymore. And it just builds up. And so that's what you want with the passives. All you want is that real quick click, and then there's no point to current moving anymore. It's just wasted current. Hopefully that makes sense. So yeah, we will come back, and I'm going to put the lamp back at a lower setting right there, and we are going to yank the capacitor. And so now it's just going to see the high voltage. No, it'd be connected to ground. I can't figure out what it would be doing just off the top of my head. So I didn't plan this out ahead of time. So let me make sure. Yep, this is 0.47 farad, replacing, or 0.47 microfarad. 0.47 microfarad replacing a 10 microfarad. So we're going to get about 20 times the speed that we got before. I'm going to turn up the lamp. And there you can see already big difference. And then I can get the flashlight, and we got that sound there. So that is probably annoying, but it is what it is. It's a demonstration circuit. Show what we can do with the buzzer right there. And so yeah, you can pick different value capacitors. This was also the small value capacitor, kind of a low value resistor there. We could go up in resistance with that resistor now, but we're going to keep this low. This is about, if you're using a 220 ohm resistor, don't go above 5 volts with a circuit like this. The resistor is always passing current as well. It's not off half the time. And so, because even when it's not charging the capacitor, it was going to ground. In fact, there's more current going when it was connecting to ground. And so you got to make sure you don't exceed the limit of this capacitor with the power supply voltage. There's really nothing taking away the power of it. So yeah, in case, yeah, this actually went on a lot longer than I thought, but I hope you found it interesting. And so yeah, there's the 220 resistor. As I said before, we were using 10 microfarad, but we swapped the capacitor. When it comes to the circuits, if you want to go 10 times faster, basically use a capacitor that's 1/10 the size. It's the resistors are a little more tricky when it comes to swapping out their values. It's a lot easier to swap the value of the capacitor to get a timing range that you like. And then again, a 10 microfarad capacitor, exact value doesn't really matter. So yeah, I think I covered everything, and that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.